Hi guys, welcome to video number 179. This one is on vectors and it's calculation and drawing. Now the keywords I've got for you are vector, magnitude, direction and scalar. You were introduced to vectors in the world of translation, which is one of the 4 transformations that you learned about. If you haven't yet checked that video out, check it out. Vectors are things that describe movements. So you go from one point in space to another point in space, and they have direction and magnitude. Now magnitude is the length of it, how far you go, and the direction is obviously the way it goes. And a scalar is just a number that multiplies something by something else. All right, so the scalar is the number that is the multiplier. Okay, so the key notation in this particular video is the arrow over the top of the letters. All right, that means let's say if you've got, for example, AB with arrow over the top like this, that means the vector of AB. All right, that's what that's telling you. And when you write the little letters in exam papers, they're bold, but the little letters technically we're supposed to write them with a little line underneath them as well. Okay, so there's just a couple of bits of notation to understand in the world of vectors. Okay, and there is much more complicated stuff on this topic, and there will be a second video on this one, which is grade 9 stuff, but this is your grade 5 stuff, top end of foundation. So to multiply a vector by a scalar, you need to multiply both the numbers inside the column vector by the number on the outside. Pretty simple stuff actually, and the column vector is what we were introduced to in the world of translation. To add or subtract column vectors, you'll just need to work on the top or the bottom numbers separately. What I mean by that is the top adds to the other top, or the top is taken away from the other top, and the bottom is exactly the same. You may be asked to draw a visual representation of the vector on squared paper. To do that, you find a starting point, you go to the number of units you need to go horizontally, which is the number on the top, and then you do the same vertically, which is the number on the bottom of the column vector. All right, so it's pretty intuitive stuff. If you were going to make up a way of doing it, this is the way you would make up of doing it. So if you hadn't learnt about it and you just made up a way of doing it, you'd probably get it right. But let's show you a few examples. So in the first question, A, you might see that with the line underneath it, like I said there. A is equal to minus 4 minus 1. So the vector of A is 4 units to the left and 1 unit down. That's what that's telling us. Okay. And B, the vector of B, is 3 units to the right and 1 unit down. We don't really have to worry about that when we're just calculating, because when you're calculating, you've got to do 2 lots of A plus B in this particular question. And all we got to do there is think of what 2 lots of A is. So 2 and then minus 4 minus 1. That's going to equal, well, 2 times minus 4 is minus 8, and 2 times minus 1 is minus 2. Okay, so that is what 2 lots of A is. All right, I can write it down underneath it if you like. And then for B, well, B is this column vector here, so plus 3 and minus 1. Right, now this is where, so we've done a bit of the multiplying with the scalar. The scalar was the 2 on the outside, and we just have to now do the adding. So minus 8 plus 3, just be careful when you're adding. So you're getting closer to 0, it's going to be minus 5. All right, and then minus 2 plus minus 1. So you start at minus 2, and then you take away another 1, that's going to be minus 3. Okay, so there's our final answer of the calculation of 2A plus B using those particular column vectors. All right, and it's not really that tricky. It's not one of those questions you think that's a trick question. Now, question number 2A, we've got a bit of taking away to do. 3F and 2Gs. So let's work out what 3F is first of all. So 3F is going to be 3 lots of the column vector F. So 3 times by 4 is 12, and 3 times by 5 is 15. And then for G, we want 2 lots of that. So 2Gs is going to equal 2 times by 5, which is 10, and 2 times by minus 2, which is minus 4. And then all we've got to do is that calculation. So 12 and 15 minus 10 and then minus 4. So what we end up with, our final answer is 12 minus 10, which is 2. 15 minus minus 4. Well, the two minuses will stick together and make a plus, right? Learned that a long time ago. So that's going to be 19. All right, just be careful there. Right, with the drawing of f plus g, I'm going to show you that you can draw these column vectors on there. We can draw what we refer to as the resultant vector. Okay, so f plus g, we just add these two. We can do it with just the adding method I've just shown you. So 4 and 5, and then plus 5 and minus 2. So we're going to get 4 plus 5, which is 9. And then 5 plus minus 2 is just 5 take away 2, which is still a positive number, still positive 3. All right. So that means the drawing that we need to do on the grid, we need to go 9 to the right and 3 up. Okay, so you have to figure out where a place to start. Now what I'll do for this one, so I will zoom in to this question so you can see it, and I'll draw it with some straight lines. Okay, now the first, you could draw this vector here, 4, 5, and it might already be drawn on there for you. You could draw that 4, 5. You go 4 to the right, 1, 2, 3, 4, 1, 2, 3, 4, 5 up. Okay, so let's do that one. So we start here. Let's start right in this bottom corner. All right, so we're going to go. If it wants to work, there we go. Oh no, that didn't want to work properly, did it? Let's get rid of that. Right. So 1, 2, 3, 4 to the right. 1, 2, 3, 4, 5 up. I don't know why it's doing that. That's a bit of a pain. Let's try one more time. Come on. Here we go. So 4 to the right, 5 up. Okay. Okay, I don't know why it's doing that. It's really irritating me now. Anyway, 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, just about got there. And then G, we can carry on from that point there. It would go 5 to the right and 2 down. All right, so 1, 2, 3, 4, 5, 1, 2. All right, so just join that point to there. So there's our vectors. Now, with vectors, you want to be drawing a little arrow that shows the direction, because vectors have got magnitude, the length, and a direction. Okay, so I'm just going to get that tool up there and see if I can draw an arrow on there. It doesn't really want me to do that for some reason. It's very frustrating using this tool at the moment. I don't know why. But imagine there's an arrow that's pointing in that direction. Okay, there you go, did one. And there's another arrow pointing in that direction, because that's the way we went, right? Now to draw the resultant vector, which is 9, 3, okay, 9 to the right and 3 up, we can go from the original point here. Okay, let's get a different colour line. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. Okay, and that joins that point to there. And that's what will always happen. Okay, and then we've got that direction as well to consider. is going that way. Okay, so just about got through that without losing my temper and throwing something towards the screen. And hopefully you've got something out of it. You understand what I'm talking about there. Unfortunately, that's going to disappear because I need to get back the drawing tool. So that goes. And we have a look at the third and final question in this particular one. So x to y, the vector of x, y there, okay, with the arrow over the top, is the vector 3, 2. You can see it on this diagram here. You see it's gone 3 to the right and 2 up. Okay, the little arrow pointing in that direction. Write down a vector that is the same size, so the same length, the same magnitude as x, y, and perpendicular, which means at right angles too. Hopefully you know that by now. So we've got to do one that is the same length. It's got to be 3, 2, right, and perpendicular. So we've got to kind of rotate it 90 degrees, all right? So that means it's going to be going to there, yeah? Now, or to there, sorry. Okay, because that's going to be our 90-degree rotation. So we want 2 units to the right and 1, 2, 3 down. So I would draw that on the diagram there. I'd be tempted to anyway. Oops. Maybe a little bit neater with a ruler and a pencil, ideally. But there's a vector that we could say is a 90-degree angle to this one, perpendicular, and it's the same length, okay? Because we've got the 3 units and the 2 units, we've got the 2 units and the 3 units, okay? We could go the other way with it. We could go this way and up here, okay? There's another example of a perpendicular and the same length, but I'll use this one. So this vector here, from here to here, we'd have 2 on the top because that's 2 units to the right, and then we'd have 3 units down, so that's going to be -3. All right, so these numbers here have just swapped and one of them's become negative. All right, hopefully that makes perfect sense to you. If we wanted to use this one, we could go -2 and then a +3. Okay, and that's done the same thing, hasn't it, as what I just explained. Now the last question asks us there to work out the magnitude of the vector xy. So I'll get rid of that there so we don't get confused. Now magnitude is just the length, and this is all about Pythagoras. Okay, and it's in the Pythagoras and trigonometry section, so it kind of makes sense we've got to use a bit of Pythagoras here. So the magnitude, we've got a right angled triangle there, so we've got 3 units there, whatever they are, could be centimeters, meters, whatever. All right, we've got 2 units there, and we just have to use Pythagoras to work out that missing length. So this is, if we're doing it properly, that's our side C, that's A, that's B. Okay, and we'll go with C equals, we'll do it the quick way, the square root of 3 squared plus 2 squared, or 2 squared plus 3 squared, doesn't really matter. So C equals 9 plus 4, which is 13, so C is root 13. Okay, now you could work out what that is as a decimal number. Haven't got the calculator, doesn't say we need to. That's an acceptable answer. I'm going to leave my answer in third form, is what that would be referred to as, right? It's root 13. That's the most exact number that I could give you as an answer. All right, so there you go. There's the world of vectors, or the introduction to the world of vectors, calculating, drawing, and using a bit of Pythagoras on them. Hope it all makes sense. Please do give me a like, or the video a like, not me a like. The video itself a like if you've enjoyed watching it and learned something from it. If you are using this resource and it's making sense to you and maths is getting easier, good, well done, continue to use it. Thank you very much for watching. Take care of yourselves. Bye bye.